I'm Georgie from the Barossa Improved Grazing Group, and today we're here to look at a soil pit. This pit is located just the other side of Moculta on Ian Cox's property. Behind me here we've got our big weather station. So this weather station monitors wind direction, wind speed, soil moisture, rainfall and temperature. So we're going to have a look at the soil pit behind me. We've got Rebecca Tonkin from Adelaide Mount Lofty Ranges Natural Resources Management Board, and also David Woodard from Rural Solutions SA.
Okay, we have a mixed farm of sheep and cropping. We run a merino stud. These paddocks are used for winter grazing. We take the sheep off probably in December after mating, and then the ewes get taken off into the stubbles over summer, and they're due to come back in here in the next week before lambing.
Yeah. And we've got the weather station behind us. This has been here for less than a year, but are you using the information that comes off of the weather station?
Yeah, I use it quite regularly, particularly winter time and cropping time. I use it for all my, when I'm spraying, for my wind direction and all that sort of stuff, delta T. Yeah, it's really handy for that. And rainfall, I just check to see the difference between my place and here, the rainfall, which it's not a lot of difference, but yeah, it's really handy. And also the soil moisture is really interesting as well.
So this is the Coff soil pit, which is sort of north of Anguston towards Moculta a bit. Again, you can see it around about that 50-60 centimetres, the parent material for this soil that you're basically forming over the top of the Anguston marble, which would have been an old limestone layer sort of laid down a long time ago. You can see even fairly shallow soil, but actually quite a well-drained soil above it. Evidence of being formed, I suppose, over that more porous calcium-dominated material, and I suppose the red colour of the soil sort of highlighting that better drainage. It's not a sandstone, so in that sense this is actually formed out of a much loamier or heavier or finer textured material, while the other two were formed out of rocks that were originally sandstone, so you end up with quite sandy loam sort of topsoils. We did test this material down here, and it would almost be suitable as a liming material for acid soils, and it's not that far from the line of quarry at Penrice.
Here at Moculta. At Moculta we're on quite a dome rise, north slope, top of the slope. So you'd expect a relatively shallow soil, but this one is quite a good depth above the lime layer, the white layer, and I guess what we can tell straight away from this pit is the good red colours suggest there's some good things about it. Red soils tend to be better drained, and also tend to be better fertility wise, just by the nature of the minerals in the soil, and so we've got quite a red layer above a white limestone layer, quite dusty, quite soft, and so we've got good drainage here. When you look at the profile, again you've got a good organic matter layer. We're in a permanent pasture, native pasture that's in amongst the gums, so we've got quite a good root system. We've got a layer there that's slightly different colour, and you'll see there it's darker again, and the clay breaks down into sections, so that's what we call quite a structured clay, whereas this clay in there is not so easily broken apart, but it does have some structure, and a good organic matter and good roots, and porosity holes. It's quite a good good soil. The best thing is to look at the sort of each layer. We try to assess the amount of clay percentage in it, because that allows you to work out how much water holding capacity it's got, just from a management point of view and interest. So we take a bit of dry soil and we add water, and the more water you add tells you that it's got a little bit more it takes before it forms a soft bolus. Is the more water you add, the more clay it's got. So that's a good thing, because it's got more clay, and with the organic matter it can hold more nutrients, and so it'd be quite a potentially fertile soil. So we ribbon it out between our thumb and forefinger, and we can get 3 to 4 centimetres. So it's a clay loam with a bit of sand in it, fine sand. So it's quite a good soil that lets water in with that organic matter, and it also allows it to drain through the profile. So even though it's a north slope and might get rain falling down the slope, it's going to infiltrate quite well. The next thing in the field we can look at is surface pH, and a lot of these soils, we're in a reasonable rainfall here, so we put drops of this from a garden centre pH kit, and so I've got these 4 layers represented. So the top soil, this lighter red soil, the dark red soil, and then into this bit of limey sort of clay. So we got the top soil, the second layer, the top of the clay, and where the clay lime is, and so we've got a neutral 6 at the pit, and then it sort of goes into more neutral colours, 7.5, and sort of that a bit dirty, more 9ish in the bottom. To test the lime, we use a bit of 0.1 hydrochloric acid. So we put a drop on there and there's no fizz. Drop on there, there's no fizz. Drop on there is very little fizz. Drop on there and a high fizz. So very high in carbonate, that white layer. Well, it is all pretty well all carbonate. In fact, it's actually a potential lime source for the landholder. He could actually mine that, because it's so soft, and because it's actually quite soft and dusty, the particles would break up quite well, and so it could be used as a lime source for treating acidity. So the pHs here are quite good. They're in that neutral range, slightly elevated in here with the lime, and that acidity also, that dark colour also suggests there might be a bit of sodium in the system as well. So we can check the soil chemistry. Looking at your 0 to 10s, you can confirm that your pH is neutral to slightly acidic, in this case at the pit, but around the pit it was more neutral. And with the lab test we had for these layers was fairly well neutral, and then slightly above neutral, and then 8.8 in calcium chloride, 8.9 in water. So when it's in that high 8s, tells you in water that it's, and in that the sodium in the system, and so the reason we're worried about sodium is that can clog pores and or get dispersed, and that's why we've done this test to see whether it does disperse. We put a little bit of lump from each layer into some distilled water to see if it forms a cloud around the lump in time. All of these have slumped, but they haven't dispersed. So topsoil to that 60 to 80 centimetre layer where the lime is, hasn't dispersed. So even though we've got a relatively high pH, that purple in this layer tells us there's a bit of sodium there. The amount of calcium in the system is keeping it, is stopping it from dispersing. So these tests confirm the good drainage of this profile. The other things on the chemistry we look at is so we've ticked pH. It's a very good level for growing plants. The nitrates are quite good, and you'd expect that with a good structured red soil can retain nitrogen in the system. The organic carbons are very good, and you can see it through the root mass, and the way it's sort of quite a bit of porosity in the soil. It's quite light for the density, like it's got a lot of air in it. So that's around 2 to 3%. Being a native sort of pasture block, and knowing the fertiliser history, that this soil is very low in phosphorus. So it's down to the natural levels of phosphorus that would have been pre-European settlement. So it might have had a bit of phosphorus on it. The sheep have probably bought phosphorus, moved it around. So this soil, if the landholder was after more productivity, he would put some phosphatic fertiliser on it, and given the rainfall, be able to grow a lot more biomass for the system. The red soils tell us it's got a lot of potassium, and it has. It's sort of around that 700 units right throughout the profile, a bit less lower down. Sulphur, high organic matter, means it's got a good pool can retain the sulphur levels, and also this red clay, because of its structure, because of its nutrient capacity, can hold that sulphur. Sulphur is washed down with the wetting front, but because of the clay nature, can still hang on to it, so the roots can access that sulphur later in the year. On the trace elements, with a good red soil like this, you'd expect them to be adequate, and they are. In fact, the trace element levels of copper, zinc, manganese are quite good for a soil that hasn't had much fertiliser in the past and may not have had trace elements applied. So naturally this soil is very good, and the red soil also tells us the cation exchange capacity, which is the ability to hold nutrients, is reasonably good. So the potential there is to hang on to those nutrients. It's also from a water holding capacity, we've got roots to they get into the lime, but they probably finish off at, like, there's some old root channels which the roots take advantage of and move down the profile, so the roots are down to 1 metre. But because there's so few roots there, we've probably looked at that has been the main root zone, and in that depth of 0.8 of a metre we can hold about 103 millimetres of moisture. And for the plant, which is plant available, not the total moisture, but what's available to the plant once it's wetted up and drained. And the other activity quite evident is the earthworms are they're imported earthworms. The Rosia family turn this castings, turn the soil over during that sort of winter spring period, and then later they go down deep and over summer in a cocoon in a tight bundle where there's a bit of moisture. So there's quite a bit of activity of that rosy earthworm here in managing this soil. Obviously it's a fairly good soil and it looks after itself, but I just wonder whether anything we've raised might be an issue.
Well, we probably didn't realise that the lime was as close to the surface as what it was, and as thick. Probably pointed out it is low in phosphorus, so it's possibly something that we can try and work on here. The paddock is reasonably undulating, so it'll present some challenges that way, but it is possible.
And you've got a good soil depth to work with. It's not as if it's this lime is up here, and so economically we're high on the hill, and you'd expect it to be quite a bit deeper as we went down the slope. Or it might stay the same, it wouldn't be shallower. So
probably pleasing to see the way the roots are penetrating through the soil and even getting to the lime layer.
That's got good drainage, and
it's nice and porous, so the water runs in
and free draining and doesn't cause any plant growth issues. Like it's a good soil for growing plants.
We have to say a big thank you to Ian and Fiona for having us here and for using their property for this weather station site. If you'd like to find out more information about this project or anything else about the Barossa Improved Grazing Group, please head to our website at www.biggroup.org.au. This project is delivered by Adelaide and Mount Lofty Ranges Natural Resources Management Board and funded through the Australian Government through the National Landcare Program.